So for this problem, we're going to look at an application of quadratics. We're given that a model rocket is launched upward with an initial velocity of 220 feet per second. The height in feet of the rocket t seconds after the launch is given by the equation h, which is equal to negative 16t squared plus 220t. How many seconds after the launch will the rocket be 350 feet above the ground? So for this problem, we could solve it using factorization, or we could solve it using the quadratic formula. But what I want to do is actually show you how you can use your graphing calculator to solve it. So first things first, what we are given is that the height is 350 feet. Right? So that means that the equation is going to equal that at some point. In fact, because it's quadratic, it's probably going to meet at that point or meet at that height more than once. So let's take a look at the graphing calculator and see how we can solve this. So here we are in a graphing calculator. And of course, its greatest strength is its graphing capabilities. And it can help us to solve many different types of problems. So we will begin by first inputting the equation into our calculator, because right now we have nothing on our graph. To input the equation, we go to y equals. Now I realize that our equation was h equals, but this calculator typically uses y and x. So we're here at our y equals. And now I will input the function into the calculator. So the function was negative, and don't use subtraction. Make sure you use the negative key, negative 16 t squared plus 220 t. When I click on graph, that's all I see. It's not very effective, not going to help us out. So we need to go to where we can manipulate the window settings. The window settings are right here. So we can manipulate how much of the graph we see, and also take into account what values the function is asking us to find. So first of all, we're dealing with a scenario where there is a rocket launched upward. So first of all, there's an element of time as well, because we got a variable that is height and time, neither of which do we need to look at the negative values. So I clear out the negative values for x. Now, the other thing is that we will likely need to, or we want to be able to see the entire parabola or the entire flight of the rocket modeled by the parabola. So I want a little bit more space. So I'm going to go to x equals 15. Now, the scale is just each tick mark that you see on the graph, and you'll see the tick marks. I'll show you when we look at the graph. So I'm leaving the scale the way it is. Once again, the flight of the rocket is up in the air. I don't need negative values for y. Now, the height that it wants us to find is when the rocket is 350 feet above the ground. I could just put 350 and then I'd be able to see what I need to see, but I want to see the whole parabola. It makes you feel more comfortable when you can see the entire flight of the rocket. So I'm going to put in a really big number. I'm going to go to 800. And I'm going to make my scale 50. So each tick mark on the vertical axis is 50. Now, when I go to graph it, I'm going to see the entire parabola. So you can see that it reaches a height and then it comes all the way back down to the ground. And if you consider 51, 52, 53, 50, that the graph is going to be at a height of 350, both rising and falling. Now, we could use our trace functionality and try and move to the point closest to where it's 350, but there is a more exact way of doing this. We are going to use what's known as the calculate functions. Now, before we use the calculate functions, we need to graph the line y equals 350. To do that, we go back to our graph, or we go back to our function input and input the value 350 for y2. That will give us a horizontal line. And notice that horizontal line does go through 350, and it does go through the graph twice. So now we want to calculate what the values of x are, because it wants to know when it's 350 feet above the ground. So we go to our calculate functions, which is above the trace key. So I press second, that gets me to the blue functions, trace. And I want the intersection point. So I want 5. Now, to get the intersection point, you want to be as close to the intersection point as possible. And then you just hit enter 3 times. 1, 2, 3. Giving me an intersection point, or giving me a time when it's at 350, giving me a time of 1.83 and so on. But the answer, the question is asking for us to express it rounded to the nearest tenth. So t is 1.8. If we want the other intersection point, it's the same steps. Second, calc 5. Now I want to travel all the way closer to the other intersection point. Otherwise, it is just going to give me the same answer as before if I just hit enter 3 times. And then I hit enter. 1, 2, 3. And I get my other result of 11.9. And in both cases, the units are seconds. Our recorded results are 1.8 seconds while it's rising, and on its descent after 11.9 seconds, it will also be at 350 feet above the ground.